we're doing is, if I got to take over completely and just talk about some stuff that I think is really helpful and useful to us all, but really, really hard, this would be it. And the reason, I'll talk a little, just a tad bit more about that reason, but what's coming up soon, starting on September the 8th, we will kick off a year-long study of basically, if you are going to make, and this is intended to be twofold, both for Christian believers and then also for skeptics, atheists, people of other religions. It is the Christian trying to make the best possible case for why what they believe is true, and not only why it's true, but how it also happens to be. So there's two things here. It's one thing to be true, because there are true things that may make you happy. There are true things that may make you sad, right? I don't know about you guys growing up, but I learned sometime around between middle school and college that I was not as wonderful as my mommy told me. This was a truth that I did not find was quite as convenient as as my beliefs had been previously. But given that there are truths that are going to make us happy and truths that won't, that both the beliefs of Christian theism are both actually true, scientifically provably, metaphysically consistent, and with our best, strongest principles of metaphysics and philosophy, and then also, happily, the best way to be happy and to gain the goals that all mankind have always pursued, which we'll talk about a little at the time. So I'm trying to make, we have talked about things in some terms very exploratorily in this class. Now we're going to make a very strong case, a very strongly stated case, and invite attack on it. And not only invite and not only tolerate attack, not only deal with attack, invite it. And the desire there is not to create hate, discontent, and difficulty, but rather, if something is true, it ought to be rock solid, adamant, impossible to ding, because it's just that true. And if what we believe isn't that true, if it is susceptible to attack, then it's probably not true in the first place. So we want to submit it to, or basically put against it unceasing assault to see how strong it is. So I think that'll be a fun project. I think it'll be an interesting project, and it's a project that I hope we've had guys. Again, hats off to Dennis for being a long-term counter voice in Solid Ground, our atheist of high repute, who for all of his atheism acts sometimes like the best of Christians in his charity and in his care for other people. But we would like more of that in here, and we will invite a lot more of that in here. So if you have folks that you think not only you might enjoy this class, but rather something like this. There's a Christian guy out there who's claiming that the truths of Christian theism not only are true, but that it's rigorously provable. He's going to do it, and he's inviting your attack. And we'll give you as much floor time as you want. Anybody that you know that might be up for that, by all means, please extend the invite. Okay, and again, our goal there is not to create debate for the sake of debate, but rather to really test our faith and prove it, or alternately find out where it's weak and figure out what we need to modify. All right, one other thing is in conjunction with that, even though Solid Ground is probably statistically speaking the greatest concentration of introverts in any one class in Reston Bible Church, we are going to have a social function on the 14th, kind of a welcome to Solid Ground. There will be two zones. The main zone is the center part of the house where people can get together and talk and share and whatever else. And then there'll be multiple introvert pockets allowed, both outside, it's a 10-acre property, and in other places. So if you don't want to be around other people, there's a library you can go in and read in and just ignore everybody else to your heart's content. There's stuff to do outside where you can do entirely on your own. There are little walks through the woods that if you do not want to see a person the entire time, you may do so as well. So I do that because I am also the prince of the introverts. Yes, sir.
Is this going to be at your house?
Yes, sir.
Can I bring my gun?
You can bring your gun, and what he means by that is we have a shooting range. We have some steel targets in there. So we have historically in the past, for those that are interested in that, done a little bit of pistol shooting just for fun. But if that's not your thing, there's a non-allowed introvert and slightly less dangerous introvert zones as well. Okay. The Hunchess for that will be Ashley Ramsey, the probably RBC's one of the most gifted administrators. What announcements do you have?
I'll be putting a sign up Genus link on Facebook. You can sign up to bring a side or a dessert or come early and help set up, or stay late and clean up and get other information that way.
Yeah,
If you don't have Facebook and you want me to email it to you, please get that to me or Scott, your email address, or just shoot an email, let us know, and pass it on.
This is a Saturday?
starting
At
at
4 o'clock.
4 o'clock, yeah. And our place is basically, if you know Ashburn, I have a map. Why am I talking like this?
Your place is in the middle of nowhere.
Our place feels like it's in the middle of nowhere, but it's actually, it's not. If you look at Ashburn here, it's probably not the best layer to do it in, is it? Here's Ashburn proper, and if you look at Beaver Dam Reservoir right here, and you go just north of it to right about here, that's where our house is. So it looks like it's nowhere, but when you get out there, in fact, taxi drivers, when I come home from the airport, I can watch them slowly stiffen as they turn down one of these roads that basically leads, it says dead end, and it goes into farm territory, and that's hairy enough, and then you make a left turn and it goes gravel road, and they're like, oh, it's all over now. But basically, we're just kind of out in a little bit of this farmland that's just on the other side of Belmont Ridge Road and Wax Pool. So about a 20-minute drive from here, but not too far out in the sticks. It's happily both, and it's just south of Leesburg Airport, if you know where that is. Yeah, if you know the Loudon Academies, the new Loudon's answer to TJ, we're smack up right behind it. So do not let Google take you through there. You can get to our house via the Loudon Academies, but it will require four-wheel drive and some sort of blade in the front to cut your way through some trees. Okay. My children have recently discovered how to do apps, if you haven't figured that out. Lots of dinosaurs riding in trucks. Who knew? Okay, what are we talking about today? I promised, I made a lot of promises last time, I hope to fulfill. One, that we have kind of a master key to paradoxes that we'll talk about today. And then two, that there's a purpose to this. And here's the purpose behind it, purpose first. And then we'll talk about like practical application of what you can do with this. I think we forget very, very often that we, in our educational system, in our society, in our churches, in all facets of what we do, tend to come at knowledge constructs, right? Think of knowledge as a building there's a foundation to some discipline, theology, science of some, physics, chemistry, psychology. There's these foundations out there. We're almost always introduced to them halfway along or further. Often we're introduced to them fairly close to the end of the top of the knowledge building. And the frustrating thing about that is somewhere it seems to me halfway through life often, we start to examine those and say, well, hang on a second, what is this based on? And as we go all the way down to the foundation, we find that the foundations are either not there entirely or are so bizarre that we would have said, if somebody told me at the beginning that this was what all this was founded on, I would not have bought it so completely. So hopefully that what I'm saying is something that resonates with you. You've felt or heard something like that. I'm here to tell you that the majority of our knowledge, it seems to me, is like that the foundations of it are highly skeptical. I'll give you an example of where it is so far off the map that we're seeing the results of it today, and it's being admitted today. In the otherwise, supposedly ironclad world of physics, you guys have heard of Schrodinger's cat. Some of you know about it in great detail. But when Schrodinger brought this up, it's the idea of in quantum mechanics, this amorphous thing that Richard Feynman says nobody understands it, and he's one of the key quantum dynamicists of all time, or educators in it for sure, and practitioners of it. It's this idea of you put a cat in a box and there's a poison pellet inside, or a poison gas inside, and there's a pellet that is radioactive, and if it decays, then it'll trigger the gas, and the gas will kill the cat inside the box. If it doesn't decay, no problem, kitty's all right. And so at this time, people were talking about quantum dynamics with the interpretation you've probably been taught, which is in high school or in college, which is called the Copenhagen interpretation. And that interpretation of quantum mechanics says that both the cat being alive and the cat being dead exist superimposed on each other, completely real as anything is, until you observe it. So it doesn't actually, the waveforms that describe both of those do not collapse into a single waveform for at least what you're examining until somebody observes it. That is to say, reality isn't real until it's seen. That is to say, if a tree falls in the woods and no one's around, no, it doesn't make a noise. That kind of thing. So Schrodinger brings this up and makes this point that the cat is both alive and dead at the same time in the box. Not because he thought that was a model of how to do physics, because he thought it was so stupid that if he brings this up, all the other physicists would be like, yeah, that's a good point. That's the dumbest thing I've ever heard. That's not true. But what happened? We did not turn around and say that's so stupid. We turned around and were like, I guess that's how reality is. A lot of people did. And then like I've said in this class before, if you learn it in AP calculus, AP physics in high school or your intro physics in college, they'll teach you this interpretation. And then you get to your senior level physics course and they'll say, well, that's not really right. That's one of several interpretations. Then you'll do it in your master's degree and they'll say, nobody believes that, really. Few do, but nobody really does work in that and thinks that that's the case. Then you get your PhD and they'll tell you, yeah, we've got actually no idea. There are at least 14 empirically equivalent interpretations of quantum mechanics, and we're not even sure quantum mechanics is right because a lot of stuff we're trying and it ain't working out so well. We've got like basically two major effects that we've found in quantum mechanics that seem to do well. This double slit experiment you've seen and a kind of attraction that happens at very close distances and highly polished surfaces, and you're like, these two feel very quantum in nature, but the rest of it, we're not really sure. But that's not what we tell the public. And part of the reason is, maybe just for terms of education, if teachers were completely honest about everything. All right, I'm going to teach you a model of the atom. It's the Bohr-Rutherford model of the atom. It's going to be this core of neutrons and protons, and there'll be like planets orbiting the outside and these shells. Now I'm going to teach it to you. It's completely wrong. Don't anybody actually think that this is true. It's really not right, but it's useful. So I'm going to teach it to you. Half the class would be like, well, I'm not listening to that, right? I'm going to get tested on it, and it's clearly worthless. So it's not but of course it's not the case that learning stuff of ways that we thought of things that turned out not to work out is a waste of time, because it at least saves us from going down the same path, right? So in any case, I bring that up just to say, even some of the most, all of that, because we have quote unquote bought a lot of that thinking, we found our way into stuff like string theory. String theory sits there and thankfully is finally dying, I think. I think people have agreed, maybe not everybody, because some of the legends, the titans of string theory, are still around and teaching in some of our best universities. But at the end of the day, people are starting to recognize that its future is dim and probably over. But we wasted decades. People writing PhDs, doing research in billion-dollar machines, all kinds of stuff, to say that it's false. But at the end of the day, there were ways to have said string theory was false without a single empirical test. And had we examined, in this case, not the physics, but had we examined the mathematics and the foundations of mathematics at its most fundamental level, we never would have built string theory. Never would have happened. So I say this to you to say, it seems to me, in our quest for knowledge, the best way to make sure that anything you learn isn't false is to start at the lowest possible level and work your way up from there. Last thing, and then to Steve. Now, how do you examine stuff at the lowest possible level? We don't have time to go examining all the foundations of all knowledge. Here's the shortcut. Ask what the paradoxes are in each one of those things. Look up paradox physics, paradox relativity, paradox quantum mechanics, paradox any philosophical system you want. Paradox is Trinity. Paradox is Christianity. When you come up with those, paradoxes are flashpoints. They are red flags that say there's something wrong with the fundamentals of what's going on here. A paradox is a red flag that says something's wrong. It doesn't mean whatever that discipline is completely wrong, but it means something about either our understanding of it or something about the ground floor is broken. And I don't commit mentally to any discipline that's got a paradox that's logically prior to the rest of the deliverances of that thing, because it's something, and maybe all of it, is wrong. Steve.
Well, certainly, and then kind of digging in where I think you're going just a little sideways, is that I think maybe certain thoughts like the trigger cat and the concept of being the ability to basically have yes and no kind of says, hey, there was logic wrong. But it also seems like other forms of thought can come from that I think, like, hey, what is truth? What is reality? And people start going into like metaphysical, like, hey, everything's relative, or there's yes and no, it's possible, and then they can go on tangents as well. So I think that the physics and the kind of forms foundations for how we think about things metaphysically and just how we think about philosophy. And so it is interesting if that is wrong. Then you have to say what were the things that have inspired other forms of thought.
Yeah, to your point, one of the reasons that we got relativity and quantum mechanics at the time that we did was because of what philosophy was saying at the time. And what philosophy was saying at the time was this kind of positivist thinking. If you can't prove something is true, then it's meaningless. And I think some people will say, it's great to say things about, not great, it's people love to say things about people who've already died and can't turn around and say what they actually would have said. So a lot of people like, Einstein really thought A. Well, we can't ask him anymore, so say it, put on him whatever you want. I have heard people say, as he was working on general relativity, Einstein realized the bankruptcy of special relativity, that there were problems in special relativity and how it was derived and how it was on what it was based that were wrong, and that something was amiss. And so, as he was working on general relativity, he realized some of that. And I think there are stuff that's provably highly suspect in special relativity, and I actually think some of it's provably wrong. I think general relativity is very good. I think it has its own problems, but they're mathematically based. These singularities that pop up are the results of the mathematics on which this is expressed. And so I think, if anything, Einstein was handicapped by mathematics that was not, at least at the topological and a manifold, the geometric manifold level, was not helpful to his thinking. So, if you think about it, it's hard to think of Einstein as handicapped, because he's so smart. And he came up with so much, but I would tell you, in my opinion, that if he had not been handicapped with some bad philosophy from Ernst Mach that was passed on to him from Mach, and some bad bases in mathematics that were kind of these post-Gaussian developments in mathematics, and some of it Euclidean in nature, that if he had a different maths, he would have hit the right answer a lot faster. And maybe we would be even further than we are today.
You say you're going to start at the very bottom.
Yes.
It could be that human beings just aren't capable of forming even a mind.
All right, so hold this one. Hold this one, because the master key that I'm going to talk about is a solution to this paradox.
If I can just add what I'm saying.
Yeah.
You can't teach an ape algebra.
Right.
He doesn't have the capability. He's incapable.
Right.
And it could be that human beings are just not capable of understanding higher levels of whatever it is.
All right, so that's basically deliverance, but let's bring that up again, because that one is one of those viewpoints that does have an answer to it, an answer that we can answer at the fundamental level. So I think I told you that in my opinion, one of the we'll address a handful of paradoxes here very quickly, or relatively quickly, like less than 5 minutes each. Some of them are ancient. They go all the way back to ancient Greece. They're some of the first paradoxes that were raised about knowledge. Some of them are fairly modern. And I'm going to try to make an argument today. And my argument is all these paradoxes are solvable, fairly, apparently correctly solvable, if you work from a couple of positions. One of those positions is that the views of classical logic are correct. And what I mean by classical is the three laws at a minimum that we talked about. The law of identity, the law of non-contradiction, the law of excluded middle. Law of identity is just A is A. It is what it is. Reality is reality. Nothing is nothing. That kind of stuff. Stuff that seems kind of hard not to accept. The second is, this is either a phone or it's not a phone. So that seems, fairly intuitively plausible as well. The other one is, it is either, it's A or not A, and when you kind of exclude the middle, what you want to say is there's not a third option there, right? So if you don't have there are expressions that allow a third option. I can't say this is either a phone, this is either Steve, or it's Dan. You can be like, no, there's a third option. It's that it's a phone. But the idea here is it's either a phone or it's not a phone. That either A or not A is something that you can deal with. So anyway, these kinds of laws are laws of classical logic. If you take those kind of as axioms, then the rest of these paradoxes are solvable. If you're willing to doubt those, which some people are, some people run into the paradoxes and say, oh, it's a paradox, maybe it's the case that us thinking logically is wrong. You can do that, but it's both intuitively highly implausible, it seems practically and empirically false, and there's no way to justify it that isn't self-defeating. So for those reasons, I'd at least start with those. If you're willing to start with those, then let's talk about some of these things. The paradox, one of the paradoxes that I think is fairly easily solvable is what's called the liar's paradox. And I think I told you that even the way that we view mathematics is influenced us by today, because Gödel's incompleteness theorem, which is notoriously difficult to understand, is basically this expressed mathematically. All right, let's talk about this for a second. The liar's paradox is this statement is false. And this is the articulated problem with it. If this statement is false, is true, the problem is it asserts it's false. And since it's true, then it's false. The other problem is if it's false, i.e. the statement is false, well, that's not true. Well, then it was speaking the truth because it's saying that it's false. Does anybody want to take a stab at what the problem is with this paradox? And this, I think, is the hardest paradox to solve because it is a kind of a mind bend. It's one of those things that in my mind, your mind is bent around it, and when you get it, everything snaps clean, but it's oh so impossible to see it up until that point.
Is it because it's reflexive, because it's talking about itself?
That does have something to do with it, yes. Now what exactly? Because you're on the right track. Okay. Well, the good news is your intuition is I think, on point. When you make a statement, so there are statements you can make that are complete. There are statements you can make that are incomplete. So I can say something like, this morning we will, yes? Yeah. Oh, nope, that was it, this morning we will. Well, I don't know that that statement is complete. Or we can make another statement that seems complete in some ways, but it doesn't carry truth value. We can say something like, blue is a beautiful tone of music. Or we can say, we might say something like, crystal is my favorite sound. So these don't make sense because we're talking about something that is not a sound, and then we're talking about them as sounds. And so the statement itself seems incoherent because it doesn't communicate anything to us. The idea of this statement is false. The problem is this right here. The statement refers to the total, everything right here. But the statement, while it has a predicate, is false, is attempting to assign a truth value to something that doesn't make a statement of truth. So we can say, if we said something like this, the statement, Scott is tall, is relatively tall, is false. That one we can affirm whether, let's say that Scott is taller than 6 feet is false. That contains in the statement a claim to truth. So there's something that is being claimed to truth, and then we're assigning it. So what we're saying is this statement, so this is Scott is tall, or 6 feet tall, that's our statement, is false. That's what we're saying. That statement has a value, and that value is false. We can say something like the Scott is less than 6 feet is true. We can do that as well. And that there we're making a statement. There's no content here. This is an empty set. There's no statement. Because what's really, the statement is this, is false. Right? So this whole thing is referring to something is false. Am I making sense?
Well, I was just going to say this. Another way to possibly say it is statement is false.
Right.
And it's like, that makes no sense.
What do you mean? Yes.
So if this statement, and so the question is, what is this statement? But if you're just saying this statement,
Yeah, and if you
referring to that word, then it's kind of like saying statement is false.
so if you say to the gentleman or lady who makes this and he says this statement is false, and you say what statement exactly are you talking about? And they're saying this statement is false, or this statement is false is true, or this statement is false is the statement that I'm talking about. Then you say no, but what is the statement? Explain to me in other terms what the statement is. When you ask to explain it in other terms, it becomes impossible because it's not referring to the whole statement. It's only referring to something that isn't there yet. It's kind of the same idea that we'll get to in a second of an empty set.
Just to switch it up a little bit and see if it's still true. The redhead says all redheads are liars.
Okay, so we'll get to that one because that one requires an extra step.
And it's an if and only if.
Yes. Yes. That's the way that we're looking at it. So in the equal sign, equals is not directionally implies, it's bidirectionally implies, so if and only if. Yes.
Yeah, if there is a green mountain, if and only if there's a mountain, and if that mountain is green.
Yes. Right. So in this case, what I'm saying, the key here is not all statements are complete. And you'll see this in mathematics. There'll be something called a well-formed formula, or there'll maybe something like a well-formed set or a well-formed idea. Those things are ones that are complete. They make the full statement. So the problem with the liar's paradox is it is not a complete statement. It doesn't actually make a truth claim. There's not something there to make a truth claim because it's referring to something. The statement is actually the label that we put on an equation, right? So maybe to sound needlessly philosophical, if I say this right here, 2 + 2 is 4, I say that's an equation. But if I say the equation, I have to specify what equation. The equation 2 + 2 is 4 is true. So if I just said to you, the equation is true, your question to me is going to be, what equation? And in order to make it make any sense to you at all, and indeed in order to be true, because maybe another equation is this, 2 + 2 = 5. So this one's true, this one's false. So if I say the equation is true, you say what equation is true? And I have to say this, the equation 2 + 2 = 4 is true. Now think about this here. The statement is false. What statement? The statement is false is false. Okay, so now think about that statement. The statement is false is false. Now let's look at what the parallel is here. The equation is true is true. It's not an equation, right? I said it was an equation. The equation, the statement is true. That's not a statement.
I see. So
It's not an equation. And in the same way that's not an equation, this is not a statement. All right, now if you buy that, this becomes a master key to the next set of paradoxes, and it will hint to you the correct solution, I think, to a lot of these other paradoxes. Let's prove that. If you're not with me yet, let me attack some of these other paradoxes, and you can decide whether this is a bunch of nonsense or not. The next one that you kind of have to go to, and this isn't going to help you much more if you don't buy into this one, so be patient, wait one more, and then we'll get to some ones that are a little easier to get into, as obviously right or wrong. What do you do when someone says this? Or I'll say this, all statements that I make are false. Okay, all statements that I make are false. So there's a problem with that. Of course, same one we identified, right? If it's true that all statements that I make are false, then that statement is false, in which case what I said was true. And if it's the case that it's true, same as the other one, right? All statements that I make, let's look at that. What are all statements that I make? let's pretend, for the sake of easy calculation, that I've only ever made 1,000 statements in my life that are either true or false. I may have said things that are nonsense that don't have truth value. So let's say that I made truth claims. Jack is very tall, compared to Steve or me. That's a truth claim, right? Let's say that I make 1,000 of those statements, okay? So here's the set of statements. Statement 1, statement 2, statement 3, ... and here is statement 1,000. You have to evaluate truth claims one at a time, right? Otherwise, you have to join them together. Jack is taller than I am, and Dan is taller than I am. Okay, you can do and, or I could say Jack is taller than I am, or Dan is taller than I am. If you do those kinds of operations in the and version, if both of those aren't true, then the final result isn't true. If put an or operation in between us, if one of them is true and one of them is false, the final value is true, at least in the way they do these kind of logical mathematics, you might say. So we can't evaluate them together. We have to evaluate them one at a time. Now, does anybody see what that does for you? If you have to evaluate all the statements one at a time, this right here reduces to 999 statements that actually have truth value, and one statement that is what? Exactly the same as this. This statement is false. So it's 999 actual ones and one that is not a well-formed statement because it doesn't actually contain a statement in it. So this paradox, all statements that I make are false, is identical to this one when you divide it out, as you have to when you assign truth value. Make sense, at least to somebody in the class, hopefully?
So, actually, you guys have a statement, I'm sorry, I can't see it. So the challenge I'm having is, I think you have to say all statements that I make, past tense, are false. Then that can be true. All statements that I make suggest future, like, infinitive, or, that you will make, and it's like, you can't know that.
Yeah, no, that's right.
It's previous to this
So
one.
if you said all the statements that I made are false, and then I guess to me it's that could be true.
Well, you're not wrong in your thinking. You're right in that the logician's joke is this: 3 logicians walk into a bar. The bartender says, "Do you all want a drink?" And the first one says, "I don't know." And the second one says, "I don't know." And the third one says, "Yes." The reason for that makes sense is the first guy says, if we all want to drink, I do want to drink, but I don't know if all the other guys want to drink. So if the second guy wants to drink and the third guy does not, then the answer to his question is no. But if we all do want drinks, the answer is yes, but I don't know that yet. So because the first 2 guys say yes, the third guy who also wants a drink now knows that the correct answer is yes. So it's not funny unless you're a logician, because you have to already know that, and nobody likes a joke explained to them.
But can you say that all statements
But-
that I make?
But consider this one, Steve. If you just extended this one and you say that there's S1001, S1002, etc., there's all these other statements that you're going to make in the future. The point to what I'm saying is that this right here, of all of those statements, that's this statement right here, that one is not a statement. It's not a well-formed statement. It's not a truth claim. So this right here, when you say all statements that I make are false, this is the only way to actually make this statement rigorously correct is to say all statements that I make that make truth claims are false. And then you might ask yourself, was that one that you just said a truth claim? And the answer is no. When you break it up, this part of it right here is not a well-formed statement.
Besides getting to the point of not having well-formed statements, what's the point of this? Because it sounds like the first point is lacking like the noun, like the invention pretty much, and then the second one here seems to be just an incorrect sentence.
Right, so let's hold on to that because I think that's right. Let's do the incorrect sentence one real quickly. Thomson's lamp paradox is going to sound very much like an ancient paradox. So there's an ancient paradox that's really confusing called Achilles and the tortoise. I think there's a better one, a simplification of it. But Achilles and the tortoise was one of Zeno's paradoxes. And Zeno said Achilles gets in a race with a tortoise, and the tortoise starts at some distance, in the forward of Achilles. Achilles is really fast, tortoise is really slow. And someone says go, and they both start. And so Achilles catches halfway up to the tortoise, but in that time, the tortoise has moved forward a little bit. So then Achilles catches up halfway to that, and in that time, the tortoise has moved forward a little bit. And Achilles then catches up halfway to that, and then the tortoise has moved forward just a little bit. And the point that he says is because Achilles has to close half the distance to the tortoise each time, and he actually adds, and the tortoise is continuing to move, Achilles can never reach the tortoise. You can actually simplify that one into this. You, from where you are, want to walk out that doorway. Can you walk out the doorway? Well, you get up, you have to close half the distance, and then from there you have to close half the distance, and then from there you have to close half the distance, and you can go on dividing those distances, the remaining distances, infinitely in half. So there's an infinite number of intervals that you have to cross. It's impossible to cross an infinite number of intervals, therefore you can never walk out the door. Now, there's another paradox. One of Zeno's paradoxes was the paradox of arrow in flight. So somebody shoots an arrow, and at any instant in time, the arrow is motionless, right? It's just kind of hanging there in the air. And because all of the arrow's flight is added up instants, that the arrow can't, well, I'm just saying the way that they articulated it, right? We'll talk about that. But what he's saying is because it's never actually moving, it's just additive instances, then the arrow, then nothing can ever move. Now one of the philosophers who heard this one retorts it without any words. He just stands up and walks across the room, and therefore says the paradox of, what he doesn't say is here's how to solve the paradox, but what he says is he's wrong. We know he's wrong because I just moved. We know Zeno's wrong about the paradox of Achilles and the tortoise, or how to walk out of a door, because we do it. We can see that it is, in fact, in reality, you can walk out the door. But solving a paradox is not as simple as showing that that something happens. You have to say why the paradox ain't any good. What's the problem with the thinking? Okay, so let's do Zeno's. I forgot who brought it up. Who brought up the? Oh yes, we'll get to your. Let's do yours right after we do Zeno's halfway paradox. Okay, so Thomson's lamp paradox speaks exactly to what you just brought up. Zeno's paradox. All right, here we are at this point x, and we're going to get to this point, x to the n, and so you have to go halfway, and then you have to go halfway again, and then you have to go halfway again, and you have to go halfway again, and these intervals continue to get smaller. And this looks like calculus to you, maybe, right? These infinitesimal intervals can be generated continually. On the one hand, so there's a solution that doesn't use the master key to this one, in my opinion, which is something like this. All right? Here, when we think of this, we think of it happening kind of on a graph. We graphed it out. There was a line. That was how it worked. But here, let's talk about we'll say the distance. We'll let this one be distance. Then this one is interval size, so size of the interval. Okay, the closer, so as you go along the x-axis, as you go along in distance, the size of the interval gets smaller. All right, so let's say it started at some point here and some size here. And how does it get smaller? Yeah. It's one of those curves like this, right? And it approaches 0 here in size out at infinity, whatever that means, right? And whatever that means is something that we will talk about here. Okay, now let's talk about something else. Because when we talk about speed, how do we talk about speed? Give me the units of speed. Distance over time, right? So speed equals distance divided by time. Does anybody see the problem with this paradox? What's the problem with this paradox? Well, the time approaches 0, yeah. Well, let's say time ticks along regularly.
I went back to the arrow, never mind.
What?
Speed drops to 0. But distance drops.
What do you mean? So when we do rate, we typically say some distance over time, right? So if I'm moving at a rate of 55 miles per hour, what stays the same? Both the distance and the time. When we talk about a rate, nothing changes. What is hidden in this paradox that is hard to grasp until you really look for it is this. when we talk about, well, what speed do we cross the interval? The answer is whatever speed you were walking, right? You're going to walk out of this room at 2 miles an hour, okay? But relative, so you moved across this at 2 miles an hour, you walked across this at 2 miles an hour, you walked across this at 2 miles an hour. But the fact that we're dividing the intervals makes us forget something. What we really ought to be saying is, what is my rate per interval? And I think of what I'm saying there. Like, in other words, how long does it take me to cross half the distance? That's really what's going on in our heads, but the paradox stops us from realizing that that's what's actually going on. So what I might say is, for me to cross the initial interval, from where you are to the door, takes me 2 seconds. And then it takes me 1 second. And then it takes me half a second. And then it takes me a quarter second. So as each interval gets smaller, the time required for me to cross the interval gets shorter. And what that means is, if you do it in terms of rate, so here's distance again, and here's the rate at which you're moving, what actually happens? You start out at 2 miles an hour, but the rate per unit interval does this. And as the distance approaches the final distance, the distance to the door, what has your speed approached? Infinite. So your speed relative to the distance is infinite. Now when you take these two right here, these two graphs, and you plot them on the same thing, all the way out to infinity, what does the resolution line end up looking like? It actually ends up going flat, straight line. So you end up with exactly what you observe in nature. You neither accelerate, nor do you decelerate. You just walk out the door and all the paradoxes evaporate. And the reason is we haven't thought about what it is that we're thinking about. We think about speed in this fixed term per fixed interval. You're actually changing the interval. That's part of the problem. So that's the non-master key approach. Yes?
You just have to add an interval to your second graph because distance changes. So your second graph's kind of messed up because distance there.
Yeah, distance. That's what I meant to say. I didn't say it that way, but distance per interval, right? Distance per unit interval. Thank you, Dan.
Could you make it even simpler and just say that how many steps you take, steps per time or
You can, and if you want to just turn it in terms of distance, how many steps does it take me to cross the interval? And the answer then, because as you get to that last step, let's say that last step happens perfectly, what you can say is the number of intervals adds up to the limit, is less than the limit of what it is for one step. So you're going to as long as you can take one step, you can cross an infinite number of intervals. And so yes, that's another way to do it. So there are 3 or 4 keys that work here that are not a master key, and that's one of them as well. But all of them have the common trait of recognizing that the paradox works because we're changing the units in the graph, so to speak. Our minds tend to think like this. This is why these things are useful. This is why when you're taught math, you graph stuff, is because if I just say the numbers, it gets confusing. But if I draw a line, you're like, oh, I kind of get it. Or maybe not everybody does, but it works for some people. Same thing. This is the paradoxes are expressed in ways that hide what's actually happening when until you graph it out a certain way. Okay, so let's talk now about Thomson's lamp paradox. Thomson's lamp paradox says it's 10 o'clock and there's a lamp and it's on, and we're going to go out here to 11 o'clock and we want to know, is the lamp on or off at 11 o'clock? And so every half interval that's left from 10 to 11, you switch it. So at 10:30, we turn it off. And then at 10:45, you'll see this is very similar, right? You turn it back on. And then off, on, off, on, off, on, off, on, off, on, off, on. And so eventually, you're flipping the lamp switch infinitely quickly. But the question is this: what state's it in at 11 o'clock? Now, there are multiple approaches to this. Some of them are like, you're talking about a physical thing. No physical thing can be moved faster than the speed of light. You'll never be able to switch it that fast. So then, if you do the math, you can figure out what state it would be in. So you tried to switch it infinitely fast, but you couldn't do it. In fact, you blow up the light switch before you get to the time, or something like that. There's another thing that says, okay, well, metaphysically speaking, since it's indeterminate, then the question is irrelevant, and therefore the paradox itself shows you that there's something wrong with logic. That's not a very popular approach, but some people take that one. Here's, in my opinion, if we use our master key, and the master key was what? Asking, is this a well-formed statement? Is this a well-formed sentence? You remember I had made the point last time, part of the master key was this. There's something that's strictly logically possible and something that's generally logically possible, strictly logically impossible, generally logically impossible. Generally, it's logically possible for there to be a married bachelor. Generally, it's impossible for there to be a married bachelor, right? Because they're contradictory. Strictly speaking, that's not impossible. You can have a married bachelor. Broadly speaking, it's not impossible. Strictly speaking, it's impossible. And what philosophers or logicians mean by strictly speaking, and forgive me, we're getting close to here. I know this is dragging on. What we mean by strictly speaking is this. If instead what we say is a married, unmarried man, there is a married, unmarried man, that is strictly logically impossible. Why? Because it says, when you kind of substitute those things, there exists an A that is not A at the same time. So it violates this core law of logic, and therefore it's strictly logically impossible. Okay. I take exception to that because we're all like, look, married and bachelor both mean things. It's the same thing. Why are we cutting hairs here? I'm with you. I don't like it. I don't think it's a good use of the term. I think we have to stop pretending that words are symbols that don't have value. What we really mean is when we say 2 + 2, we mean 4. Yes, 2 + 2 is not the same as 4. I get it. These are two numbers with an add sign in between. But when I ask you what is 2 + 2, you understand it to mean what's the value? What's the final number that's there, right? So since we all kind of know that's what it means, or that's what we think, yes, fine, technically, let's spell it out. But at the end of the day, 4 = 4, not 2 + 2 = 4 in strict logical wording. So Thomson's paradox, when you write it out, it's basically saying this. Because remember, these numbers were important. If you just say, I'm going to infinitely switch it on and off, you can come up with basically whatever answer you want. What's important is that the interval is specified to be a certain length. Over the one interval I long, what happens, this is really what the question is, when we change state based on crossing the number of intervals not I, L. Right? It's an infinite number of intervals is what we're saying. We're saying over this one interval, there are an infinite number of intervals. Which one is it? Can't have both. Which one do you want to talk about? Do you want to talk about the one interval? Do you want to talk about 1,000 intervals? Do you want to talk about an infinite number of intervals? Which one do you want? You can't do them both at the same time. In the same way that you can't be a married bachelor or a married, unmarried man. The master key here is the same as the statement. This statement is false. That which is not a statement is a statement, is really what that thing is saying. And that statement has a truth value, which is false. So, for those that are not deep into the philosophy part, as I apologized to you before, this class is probably not going to be your favorite. But let's now talk about some of the paradoxes that exist out there that we care about. What paradoxes do you care about that you've heard about? And let's apply some of this to it and see if it works. And raise your hand because I'm going to keep talking until you raise your own. This is why, in set theory, this is again something you may not care about unless you're really into the math. One of the axioms says that there's a set, that a set is this. A set is a collection of objects or elements. We'll do that. Objects or elements. That's what a set is. And they say there exists a set that they call this, the null set, and that set is empty. Now what's the problem when you say the null set exists? That statement is, strictly speaking, there's a set, there is a collection of objects or elements that is not a collection of objects or elements. Okay? This is the basis of all the mathematics that we do today in number theory, in set theory, which is the dominant thing, has this at the heart of it. Now I bring that up to you for some key reasons. If you want to be the most important person in the 21st century in math and physics or whatever, solve this problem. Don't go solving the problems halfway down the way. Now, halfway down the way, they may have some practical application, that's true. But there's going to be something that's still going to cause other work for people that you didn't need. This is the stuff to solve, because if you can come up with a mathematics that don't have this problem, the math will now be logically consistent. And one thing we know about reality, if we know anything about reality, it's this: it has to be logically consistent. Okay, and so I'm saying that this is contained, all the problems we have with general relativity right now, one of the problems, major problems we have about general relativity, in these Einstein field equations, there's this factor in here. Here's x, here's something over the radius of the object, planet, sun, black hole, whatever else. And what's the problem with having the radius on the bottom? What happens when your radius approaches 0? Everybody remembers this from math. You can't divide by 0, right? You're not allowed to do it. It's against the rules. But what stops a black hole or something from crunching down to 0 size? Or remember, the universe was supposed to start as a singularity too. The fact that this is contained in the Einstein field equations is the reason that people say there's something wrong with general relativity. It can't be completely right. That's not Einstein's fault. That's because we're using a mathematics that only allows you to express it in these terms. Now, why am I saying this? One of the best math educators I've seen out there has said, you know why it's hard to understand math? Is because people act like it's not a language. Math's just a language. When you say 2 + 2 = 4, what you really mean is, when I take these two things and I group them with those two things, then I now have 4 things. Like that's not rocket science. That doesn't seem hard. Every statement out there in mathematics is actually that simple. We just forget that they're statements. All of this is in terms of language, and if you don't have your language very solid, if I say something like, Steve, I think that I should turn this way to go out of the class to go where I want to go, and Steve says, that's right. Well, wait a minute, does that mean that Steve is affirming that that's the direction I should go? Or did he just tell me, no, the direction of your turn is right? So there's this word that we use, right, which both means turn this way and also means correct. And the fact that we have a word that means 2 different things will allow for confusion. This is why having the language correct is important. And that counts for math, and it counts for philosophy, and it counts for Christianity and religion and all that other stuff. One of the reasons I think, and the thing I'll get to last here in a second, is the Trinity. We should not have paradoxes in our own thinking, and it's good to build a tool set first that lets you unlock paradoxes, because then at a minimum, what you won't do is approach them and basically be like, I don't know. And I don't know is a correct answer because I can see this paradox. What you can say is, no, if it's a paradox of this type, it does have a solution, which means something's wrong here. Now, unfortunately, this is not Dennis's speed, so he's out. But the answer to Dennis's question, which was, mankind may not even be able to comprehend reality at all. Does anybody know the problem with that question or statement? What's the problem?
How do you define reality?
Mankind, men, whatever, cannot make any true statement about reality. What about that? We know for a fact that either this is not a well-formed statement or it's self-contradictory. Because if you can't make any true statement about reality, then that statement is not true. There's at least one statement, i.e. the statement, you can't make any truth about reality, that would be true. It's the same answer to the question of like, well, reality is subjective. Or which is another way of saying, there are no truths that are absolute. Is that truth absolute? So it's either the case that it's not, I have answered this in the past by saying that's a contradictory It's self-contradictory. It undermines itself. I think that's right. I think you can look at it and say it undermines itself. But it's more accurate to say it's not well formed. Mark, and then Steve.
The null set thing. If it's necessary to have a null set, can't you just redefine set to be a collection of elements of objects, including a collection where all the elements or objects have been removed? I mean, if you just redefine set, then there's no contradiction there. What am I missing?
No, you would be right, but then to be a little nitpicky about it, when you talk about a set, what you're actually talking about are the brackets. And when people, in my opinion, when people are talking about set theory, some of them don't realize that they're actually just talking about the brackets. Because the way they construct infinite sets is to say there's the null set, there's the set that contains the null set, there's the set that contains the set that contains the null set, and that's actually how, and ... that's how they build the infinite set. Now really what you're doing is you're saying, and John von Neumann, one of the smartest mathematicians of the century, said there's another thing called categories that we need to talk about, and they sit above sets. And these correspond one-to-one to the natural numbers, or to the integers, or whatever, or however you want to do it, if you want to turn them around. But look at this. There are 0 brackets here. There's 1 bracket here. There are 2 brackets here. So I think your intuition is exactly right. Now consider that. We've got guys with 180-pound brains, and gals with 180-pound brains sitting out there thinking on set theory, and that only occurs to a handful of them after they've looked at it for years. You are a smart guy, Mark, but you're sitting here in a class, we're exposing this to you the first time, and you've come up with that same intuition. This is very important. If you think that Mark's right about that, if this makes sense to you, if you think von Neumann is right, that we're just counting brackets, basically, then the point is, John von Neumann, talking about core reality stuff, Mark, come to the same conclusion in much the same period of time. Why is that useful to us? You don't have to be a super genius to comprehend the most fundamental truths that are out there. That's the important thing in there. And I think that if there's a God out there and he cares about us discovering truth, the most foundational important truths are simple enough that the densest of us can understand the ones that matter. That's important. I'm not saying this paradox stuff that we're talking about, we've complicated it a lot. But if you ask one of the dimmest guys and gals that you know about, hey, do you think that can be a truck tire and not a truck tire? The guy would say, you're not making any sense, man, right? And he's affirming the exact same truth that you and I are affirming when we make some more sophisticated philosophical statement that sounds fancier, but it's really just saying the same thing. You can't both be A and not A at the same time.
Going back to what Dennis we were talking about, I don't want to speak for Dennis, but to maybe even say just, I'm not sure how to phrase it precisely, but basically to the extent that, there are things that we can't fully understand, and if we can't fully understand it, we can't make comment. In other words, there's certain limits to what we can perceive, and if there's limits to what we can perceive or understand, then there are limits. That doesn't necessarily mean we can't make truth claims. It just means, if the entirety of reality is, this massive thing that we have, and that we can only see a small fraction of it,
well,
then it's maybe.
But I think you're
outside that fraction that are important.
Yeah, but I think you're making my point. So let's say that it's the case. Let's say that it's like secretly, amazingly, and fundamentally true that we will never understand everything out there. Let's say that. I mean, that seems intuitively true, right? But we will never understand everything out there. In fact, there's no hope of it. But Steve, you sitting here in this room just made that statement. Right? That is a huge statement, not only about this room, not only about this massive planet, not only about our solar system, not only about the galaxy, not only about the galaxies and old universe, all of reality, metaphysical and physical. You've just said the following: the mind of man will never be able to comprehend all of that. That's either true or it's false. It means that you have made a claim that is so broad it touches all that is. And you framed it in such a way that it is either true or it's false. Now, it may be the case, but here's the important thing. If you restate it a little bit, if you say, the mind of man can never know anything that's true or false, then you've already made that big statement, and now you're back into the master key. It's either the case that that's not a well-formed statement, or more likely what you can say is, not counting this statement, there's all of reality out there, and we can't understand even one little bit of it. In order to make that statement, look at what the subject of the sentence is, all of reality. Your mind has just conceived in some way. You have put brackets around all of reality. So somehow you recognize that there's something out there potentially called reality, and then you want to make truth claims about it or something. You just have done that which you're saying is impossible, or might not be possible.
So the inverse be their man can understand the whole of reality.
Yeah, let's say that you want to make the stronger claim instead of I can't understand anything about reality. Well, I'll never be able to understand everything about reality. Fine, I don't think anybody's been out of shape about that. What we want to say is we want to understand some things about reality, and we want those things to be correct.
Yeah, I think
Right?
that's what I'm trying to.
Which it is. I'm just trying to break it out for you that there are two separate questions there that you can, at least two separate questions you can ask there. Now is it the case, now let's assume for a second that there's something like God out there, that God is out there and he wants us to understand things. Do you think that what he wants us to understand, do you think that he cares that we understand all of it? Here's an argument for why he may not want us to understand all of it. We'll make it up. You know, a brain's got 80-something billion neurons talking to each other. Each one of them in some combination can only hold some number of facts, 10 to the something facts. I don't know what that number is, but it's massive, right? Some massive number of facts. Those number of facts significantly less than the total number of Planck intervals that ever have happened and potential movements of atoms in the universe. It is mathematically impossible for the human brain to store all of the states that the universe has had up until this point, even if the universe is very young. And so it can't be the case that God wants us to know all propositional truth. The state of this part of matter at this time in the universe was X. Not physically possible. Can never build a computer out of the universe that does that. We can never we can never know that in our minds. So God has already limited us to as what we can understand by the size of the brain versus the size of the universe in time and space intervals at whatever distance you want to cut the time and space intervals. Right? Doesn't matter what distance you want to cut them. So if that's the case, God's already told us, I'm not interested in you understanding everything. Okay, what is he interested in understanding? Well, that's part of what the Christian viewpoint does, is tell you what does God think is important, why does he think it's important, what does he want you to know, and the amazing thing is, for those that are turned off by this kind of stuff, the stuff that he cares about is not whether you understand these paradoxes or not. What he cares about is, do you love him with all your heart, mind, and soul? Do you love your neighbor as yourself? Do you understand the nature of love? Do you want to get to know God? Some people in this room want to get to know God because they love God as an engineer, and they like to understand how he did his engineering. They love God as, you know, some people love God as a person who expresses emotion or feeling towards someone. Ideally, we all have some part of that, and we do. But at the end of the day, some people are going to tend in one direction, some people in another. So mostly this kind of stuff that I'm jabbering on about today is for the people that want to love God with all their mind, and the mind that God has given them happens to be one of the minds that is interested in this kind of stuff. So I think that God, one of the reasons God made the universe so big and so complex and made our minds as incisive as they are, is that the people who are bent that way, that he has equipped that way, can in fact find unplumbable depths of joy in the knowledge that he set out for us to know that also reflect who his character is. And the same is true when it comes to feelings of love. You'll never plumb the depths of God's love. And the experiences that you have in this world can hint you in that direction in the same way that knowledge in this world can hint you in that direction. But at the end of the day, and forgive me, I'm going to finish rolling here really quickly, so let me cut off some final questions and say, when it comes to solving these kinds of paradoxes, okay, so twins paradox and relativity, all of Zeno's paradoxes that arise in the foundations of mathematics. Now let's talk about one quick one in Christianity. because there's a really cool set of videos out there that I came across a while ago called the Bible Project. Have you guys seen these on YouTube? They're kind of these animations that talk about, who's God, what are angels supposed to be, what's the heavenly council, what does Elohim mean, what's love in the Bible, what's sin, what does the word sin mean? And they're doing kind of like a Hebrew and Greek word study, but they go and they do a fairly good job. I got a little irked because one of the things that they said, they do one on God, and they talk about the incomprehensibility of God. Now, I will say, yeah, it's probably the case that we're not going to understand everything about God. But I also think it's the case, they basically say, as impossible as it is for a two-dimensional person to understand a three-dimensional object as it moves through that two-dimensional plane, and they do a kind of a good job of explaining that in the video, so too is it impossible for man to understand the nature of the Trinity. I don't think that's true. I think that's given up. I think it is possible to understand the nature of the Trinity. I actually don't think it's terribly, terribly difficult, but it takes a commitment of not giving up and calling it a mystery. And so if there's a paradox in there, and let's say there is a paradox, let's say that the paradox is the way that one of the shield of faith, as it used to be called, where it's got the Father, the Son, and the Spirit, and it's got the word God in here, and it says the Father is God, the Son is God, and the Spirit is God, but the Father is not, the Spirit is not, okay? So the problem is, on its face, if you don't make any further clarifications, all this is a really good diagram of a violation of the law of non-contradiction. And unfortunately, we have bought that, and we just are like, oh, okay, it's ineffable, we're not going to know it. Well, you know what? If you're going to accept that, then don't get mad at the atheist who, when you lay out a really good argument for God, says, well, I see that you say A, but I say it can be A and not A. And you're like, no, that's not how it works. This is good, rational reasons to believe in God. You're not listening. But at the same time, you're like, no, I'll affirm this. It's just a mystery. I don't know how. You can't do that. Unfair. You're violating your own rules. Not allowed to. That's not good. That's hypocritical. Don't be hypocrites. Do the work on your own side. And the whole take the log out of your own eye before you take the speck out of your brother's eye, or alternately take the splinter out of your own eye before you try to take the splinter out of the other's eye. That goes for theology and philosophy too. So let us be, and this will be the theme for us over this next year. Let's not be too willing to poke the atheist, the Muslim, the Jew, the agnostic, the Hindu, the secular humanist in the eyeball about the consistency of their beliefs until you are confident, demonstrably confident, that you have a system of faith, a systematic theology that is, wow, I've been drawing in completely different scales, haven't I? That is logically consistent. That all the pieces of your belief system lock together without any contradictions in them. And this is why I'm what I would call an epistemological, let's say a knowledge minimalist. You don't need to believe 1,000 things. You need to believe some small number of correct things. Better to believe 10 true facts than 1,000 facts, 90% of which are false, because it's just too confusing for you. So what I would say is, before we wax eloquent about exactly what the hypostatic nature of the union of God and man is in the Son, let's make sure that we have the basics down. And this is why I think there's something to be, and the best places to identify. Remember what I said. Well, okay, fine. Then where might my theology be wrong? Where's there a paradox? Okay, God's sovereignty, man's free will, it's a paradox. I don't know. Nope, red flag, something's wrong in your theology. Okay, well, God's three and that one at the same time, I don't know. Nope, something's wrong with your theology. Red flag. Go to your red flags, satisfy those first, then work your way through it. This is on the intellectual side. Praise God that there is an easier version of this one, which is, God's not going to ask you, I think he does want you to pursue this knowledge, but he's not going to ask you to act in your life like, how am I going to treat my wife, my girlfriend, my husband, my boyfriend, my enemy at work, this guy in the street, the guy who cuts me off in traffic. At no point in there do you have to resolve any particular paradox about the way that these logical things fit together. You know what you need to do? Love the person, right? And at the end of the day, the person who is greatest in the kingdom of heaven is not going to be the person who derived the most correct truth propositions about the way the world is. Because let's say something like, well, when we get to heaven, you can just ask God, God, is general relativity right? He's like, no, here's the right equation. It's a lot simpler. There's just one of them. Right? You don't need 100 years of study to do that. God's like, yeah, there's the answer. You know what God can't give you the answer to? Hey, love, I'm going to force you to love this person. So I'm not saying this is useless, but what I am saying is, how often have our rigorous beliefs in something prevented us from dealing with somebody else? And I'm talking about facts, apparent facts, not the Trinity, and maybe with some those things, yes. Calvinism versus free will stuff, Catholicism versus Orthodox. I can play guitars in worship music versus I can't play guitars in worship music, right? These are all real things. Not only those, think of the following things. This person hurt my feelings because of the following facts. We disagree about the following facts. That's exactly the same thing. Exactly the same. One of them, there's a fact out there. God wants us to worship in a certain way. Let's say that's the case, or a certain set of ways. We disagree about that one. Now we got all upset at each other. There's some fact that actually happened in the past. This person said this, and I said that, and now this person is upset at me, and I'm upset at this person. It's the same thing. It's a disagreement about facts. So whether it has to do with highfalutin philosophy and theology, or whether it has to do with whether you said something that you thought was said sharply and the other person didn't, all the same. No reason to get bent out of shape about that. Love is supposed to be the rule. So the reason I say that, so why did I bother talking about the paradoxes in the first place? These should spur you to humility in knowledge. That by the time you consider all the paradoxes that are out there, until you have resolutions to all of them, and then you subsequently build the real knowledge that isn't paradox-based, nothing that you know is right. That's the real conclusion, is nothing that you know is completely right. Nothing you know mathematically is right. Nothing you know scientifically is right. Nothing that you know is 100% correct. Take that into your personal lives. If that's true in like the smartest guys and gals we've got are doing this and they still can't get it right, how about the rest of us average Joes? In your personal lives, even the stuff that you are certain is right, the facts about who cares about who spoke to who in a certain way, those are also filled with inconsistencies, untruths, and most of them are based in assumptions that are false, just like some of these things are based in assumptions and systems that are false. So the rule, the law of love, is that which overcomes all of this and says the following. It is the law of love is the philosopher who, when he hears the paradoxes that says he can't move, he stands up and he walks out of the room. And what he says is, I don't understand it, but I can prove that it's false, and I will do it. Go do that. Go love where it feels like it doesn't make sense to love, and you will be the only person who ends up walking out of the room. While everybody else is paralyzed, sitting in the room being like, how can I even move? I don't know how I can even move. All right, I've gone past our amount of time. Do you have one last comment? And then we'll...
I was just thinking of, and it's maybe a poor analogy, but faith paradox. And what I mean by that is, I know that loving God, or I believe that loving God and doing certain things like praying and just certain actions are good, yet I don't do them.
Yes.
The question is, do I really believe it? And the answer is, I kind of do, but why don't I do it?
Okay,
And
so
I don't know if that's really, but that's something that I've been wrestling with.
all right, so I'm done with the, unless anybody's just dying to talk about some other paradoxes next time. I'm done with the talking about the high philosophy stuff. Next time what we'll do is get into this a little bit and say, if you take all kind of the truth and solid ground that we've been talking about all the time, what does it reduce to when it comes to what I'm going to practically do on a day-to-day basis? If there's one class in solid ground you don't miss, it's the next one, because the next one counts. This is what to do with all that, and that'll be part of the answer to your question. Thank you all very much. Please have a great week. And again, if you can think of ways that we, the class, can advertise and bring in a lot of these folks. I know some to whom to reach out. Personal invite is big. Reach out to some of the folks that you think would either benefit from the class or helpful, that we would benefit from them being in here, that are willing to challenge, willing to talk, willing to share, that kind of stuff. Please bring them in and tell us if there are ways to do that more broadly than we're doing right now. You guys have a wonderful week, and God be with you. Remember to love everybody.